Imagine a world where turning 80 doesn't mean slowing down, but thriving, where degenerative diseases stay minimal, and you remain active well into your 90s, or even beyond 100. Scientists are edging closer to that vision. Aubrey de Grey's famous 2005 TED Talk sparked a wave of interest in ending aging, laying out a roadmap for pushing the boundaries of human lifespan. Let's see how this dream has evolved since then, and what new breakthroughs may finally get us there. Why we age. Aging stems from multiple biological processes, like DNA damage, metabolic waste, and senescent cells that stop dividing yet hang around, causing inflammation. Aubrey de Grey originally coined them 7 deadly things, from mitochondrial mutations to extracellular junk. Over time, these accumulate, leading to organ failure, slower repair, and all those classic age-related ailments. The big idea behind anti-aging research is tackling each damage type systematically, so the body remains in a youthful, functional state. Aubrey de Grey's roadmap. De Grey proposed addressing each root cause one by one. For instance, if you can remove senescent cells, sometimes called zombie cells, you reduce inflammation and restore tissue function. If you can fix or replace mutated mitochondria, you prevent cells from losing their energy-making capacity, repairing extracellular crosslinks, removing intracellular junk, reinforcing the immune system. These collectively keep tissues youthful longer. Over the past 2 decades, multiple labs expanded on these concepts, from the SEN's Research Foundation to new biotech startups. Recent breakthroughs. Today, we see real progress. Senolytics, a class of drugs that targets senescent cells, showed success in mice, extending healthy lifespan. CRISPR gene editing addresses inherited diseases at their source. Some trials even focus on reversing certain aspects of aging in muscle or eye cells. Scientists have partially reprogrammed older cells to a younger state by flipping certain epigenetic switches. These small wins feed optimism that at least partial age reversal might be possible. Is immortality realistic? Critics say halting aging entirely may be unrealistic anytime soon. Metabolism is insanely complex, and you'd need multiple interventions working seamlessly. Even if we slow or reverse some aspects of aging, do we risk new imbalances? Plus, if lifespans drastically extend, how do we handle population growth, resource demands, or extreme wealth gaps in access to these therapies? It's not as simple as flipping a genetic switch. One 2022 mouse study used partial gene therapy to restore certain youth markers in older rodents, effectively reversing some epigenetic signs of aging. While it's not a magic bullet, it's a hint that what we saw in 2005 as distant might be creeping within reach, especially as CRISPR costs drop and researchers refine safety protocols. Future vision. So what does an anti-aging future look like? Perhaps annual repair treatments, removing senescent cells, or patching up DNA errors. Our 90-year-olds might remain physically active, cognitively sharp, continuing to contribute to society. Big ethical questions pop up. Distribution fairness, potential overpopulation, or how health insurance copes with folks living 120 years. But the benefits, realist disease, vibrant elder lives, are undeniably alluring. Aubrey de Grey's TED Talk in 2005 lit a spark, raising the possibility that aging could be tackled like any engineering problem. Now, nearly 2 decades later, the conversation has advanced from fringe to mainstream biotech labs securing major funding. We're not guaranteed immortality, but life extension is real enough that your children or grandchildren might see a world where old age doesn't limit ambition. If you're intrigued, subscribe for tomorrow's breakthroughs, where gene editing, senolytics, and epigenetic resets might rewrite our final chapters into brand new beginnings.